In this class, we're going to talk about mathematical induction. What exactly do we mean by mathematical induction? Mathematical induction refers to a process that is used to prove a stated result which has reference to a variable integer. You see, in mathematical induction, all you are going to be asked to do is to prove whether this is equal to this. For example, whether you're going to be given an expression. Now, you are going to be asked to prove whether the expression or the stated result is equivalent or not. Are you paying attention? Now, in dealing with mathematical induction question, there are some important steps that I want you to take note. Okay? Don't forget, in simple terms, mathematical induction, you are dealing with proof. You get what I'm trying to say? Now, there are some important steps that you have to take note in dealing with mathematical induction question. And the first is that you have to test. Please pay attention. You have to test whether the stated result is true for the value of n equals to 1. Okay? The steps. I'm just trying to tell you the steps now, okay? So pay attention. You have to test whether the statement is true for n equals to 1. Are you paying attention? Now, this is the first step. The second step, you have to test for the statement whether the statement is true for n equals to k. Now, for this second step, this one is basic step. You understand? Basic steps. Please pay attention. Basic step. This is induction step. Induction step 1. Now, the first step is that you have to test maybe the statement is true for n equals to k plus 1. Okay? This one is induction step 2. Okay? Induction step 2. Please pay attention. You see, by the time we solve multiple examples on mathematical induction, you will be able to solve question on it. You understand what I'm saying? Okay? So these are the basic steps that I want you to master. Okay? I want you to master. Remember this step because we're going to use it in solving questions on mathematical induction. Okay? Now, let's proceed to solve a typical example. Having learned the basic step, let's proceed to solve a typical example of mathematical induction. Okay? Take this question. Prove that 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 is equals to n raised to the power of 2 for all value of n being an element of a real number. Okay? We are asked to prove that 1 plus 3 plus 5 dot 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 plus 2n minus 1 equals to n squared. Now, we are going to use, this is the step that I told you, you understand? I explained that this is the step that you're going to follow. You have to test if this expression, like if this stated result satisfy all these three steps. Hence, that means that the statement is true. You understand what I'm saying? Okay, now let us proceed. The basic step says we should set n equals to 1. Okay, solution. Okay, the basic step says we should set n equals to 1. So in that case, I'm going to set n equals to 1 as in the last term. For the basic step now, you focus on the term that is here. Okay, because this is where n is present in the left hand side of the equation. Okay, this is the left hand side. All this side that you see here before the equals to sign is the left hand side, and after the equals to sign, the all the value that we have here is the right hand side. Okay, so now because n is present only here, we're going to make use of only here. You understand? The left hand side now is what? The left hand side is 2n minus 1, and the right hand side RHS is what? Is n squared. Now we want to test maybe when n is equals to 1, the right hand side is equivalent to the left hand side. Okay, now the left hand side is what? 2n minus 1. So when n is equals to 1, what will be 2n minus 1? 2n minus 1 will be, that means I'm going to have 2 multiplied by 1 minus 1. That will be what? 2 minus 1, which is what? 2. Okay, you can see that when n is equals to 1, we have, oh sorry, no, 2 minus 1 is 1. I made a mistake. Okay, 2 minus 1 is 1. Okay, now let us test when n is equals to 1 for the RHS, that is the right hand side. We are going to replace n as 1, so I'm going to have 1 raised to the power of 2. 1 raised to the power of 2 is what? 1 times 1. 1 times 1 is what? 1. So that means that the statement satisfies the first step, okay? We are testing this statement, whether it is true for all the steps. So the first step is that we have to set n equals to 1. Now, when I set n equals to 1, I discover that the LHS, which is the left-hand side, is equivalent to the right-hand side. Because all the results both produce 1, okay? So that means that it satisfies the basic step. Now, the next step is that we have to test. Maybe it satisfies the induction method 1. The induction method 1 is that I'm going to set n equals to k. You understand? So, please, I want to pay attention. I can erase this now. I can erase this. Now, let us proceed. So, when n equals to k, now, please pay attention. You see, when you are dealing with the second step, which is the induction method 1, you have to write out all the terms that you have before at the left-hand side. You understand? Don't forget that I told you that the left-hand side is all the value that you have here before the equals to sign. So, now, you have to write out all the terms. I'm going to have 1 plus 3 plus 5 plus now 2n. Now, because we are testing for the second step now, n is equals to k. Okay, so I'm going to replace n as k. So I'm going to have 2k minus 1. And another thing that I want you to note is that now when you are dealing with the induction method, you assume that for n it is equals to k, the value is the statement is true. It's just an assumption. We have not verified. You understand what I'm saying? We have not said that the statement is true. We are just assuming. You understand what I'm saying? So we assume that when we set n equals to k, the statement is true. Are you paying attention? So now, replacing n as k in this left-hand side of the equation, I'm going to have 2k minus 1, right? Yes, plus 2k minus 1 is equivalent to what? N squared. That will be what? K squared. Okay? Now, we assume that it is true. Let us put it as equation. Call it, maybe we should call it equation 1. Let us, I just want to make it as simple as much as possible, okay? So let us call it equation 1. We assume that it is true. Now, this is the induction method 1, right? Yes. Let us proceed to the induction method 2. Now, we are asked to set n equals to k plus 1. Now, it is very important to pay attention here. Do you know what you're going to do first? The statement that you get when n is equals to k, please pay attention. Now we are dealing with n equals to k plus 1 now. You understand? The induction method 3, the induction method 2, when n is equals to k1, we have to set n equals to k plus 1. Now, you have to, the statement that you got from the induction method, from when n equals to k, you have to put it first. Are you paying attention? Then, you can now proceed with n equals to k1, k plus 1. This is what I'm trying to say. This one is for n equals to k, right? Now, we want to do n equals to k plus 1. What I'm trying to say is that you have to put everything that you have at the left-hand side here, when n equals to k, you have to bring it down. Are you paying attention? So I'm going to have 1 plus 3 plus 5 plus 2k minus 1. All the things that you have here, all the values, all the terms that you have here, you have to bring it down. When you are dealing with when n equals to k plus 1, all the terms that you have when n equals to k in your right and at the left hand side of the equation, bring it down. You understand what I'm saying? Then now you cannot proceed that n equals to k plus 1. Go back to where you have the value of n in the question that you are given. We have the value of n as the last as the term here. So I'm going to have plus 2, open a big bracket, plus 2 multiplied by k plus 1 minus 1, okay, close the bracket again, equals to now n squared. That will be what? K plus 1 squared. Now, if you have any question, I know you have many questions. There are many questions in your mind, so let me answer it one by one. You are asking me that why don't we bring this k squared as well to the other side? No, you're not going to do it like that. Okay, this is how you're going to do it. When you're dealing with n equals to k plus 1, only focus on the left hand side when n equals to k, bring it down first. Then when you are done with that, you can now proceed to substitute the value of n equals to k plus 1 into the parameters that have n at the left hand side in the question that you are given. Do you understand? So don't include k squared because you brought down what you have here. Don't include k squared at the right hand side. Okay, it only works for the left hand side of the equation. Do you understand what I'm trying to say? Listen to the explanation again. You might be wondering that why don't we include k squared at the left hand side, because we actually brought what we have here as the left hand side when we are setting n equals to k plus 1. That is what you are trying to ask me. Nevertheless, I'm trying to explain now. You are not going to include for the right hand side of n equals to k plus 1. Don't include k squared, please. If you include k squared, you are not going to get the right answer. Okay, so now I'm very sure you understood it to this point. Okay, kudos to you. Maybe I should explain again because the way you are, just pay attention. Okay, what I did here is that I brought this 1 plus 3 plus 5 plus 2k plus 1. I bring it first, then I discover that I need to substitute n equals to k plus 1 here also. So I bring this value that you see here, but instead of n, I replace it with k plus 1. That's what I did. I've not done anything. Now, what we want to do now is that we want to check maybe this what we have here is equivalent to what we have here. Okay, so let us solve. We want to simplify now. Let us simplify now. Call this one equation. Let us call this equation 2. Okay, the reason why I call it equation 2 is because I just, if you are solving this in the exam, you might not include equation 1 or equation 2. You understand what I'm trying to say? The reason why I call this equation 1 and 2 is because I want you to understand. Okay, now pay attention. We have 1 plus 4 1 plus 3 plus 5 plus 2k minus 1 at this side, right? Now, but from equation 1, please pay attention. From equation 1, all these things that you have here is equivalent to k squared. I hope you know. Listen to the explanation again. If you didn't understand, listen to the explanation again. It's simple, okay? What I'm insinuating is that, listen, you know that 1 plus 3 plus 5 plus 2k minus 1 is equivalent to k squared. Now we have 1 plus 3 plus 5 plus plus 2k minus 1. I can replace all these by k squared. You understand? So I'm going to have, what I did is just substitute equation 1 into equation 2. That's what I did. Okay, so I'm going to have k squared, because all these things that you have here, 1 plus 3 plus 5 plus 2k plus minus 1, all of them from equation 1, all of this is equivalent to k squared. So instead of writing all this, I replace that k squared. Okay, so I'm going to have plus 2, open the big bracket, plus 2 multiplied by k plus 1 minus 1 is equals to, now, k plus 1 squared. Okay, so do you understand to this point? Yes. Now let us proceed. From this point, let us now simplify and check. Maybe we are going to arrive at the same answer as the left hand side and the right hand side. Okay, so for this I'm going to have k squared plus, now let us open the bracket for 2 times k. That is what? 2k plus 2k. 2 times plus 1, that is what? Plus 2. Now we are going to bring the minus 1. Okay, equals to, now here we have k plus 1 squared. That means I'm going to have k plus 1 and k plus 1, right? Yes. Okay, because if you have a squared simply means a times a. You understand? So for this we are going to have k squared. Now 2k plus 2, okay, plus 2k plus 2 minus 1, that is what? Minus 1, right? No, plus 1, sorry. 2 minus 1 is 1, okay? Equals to, now for the left hand side, please let us quickly simplify it here. If you have k plus 1 multiplied by k plus 1, I'm very sure you are part of our class on algebraic expansion. We are going to expand this. Expansion simply means removing barrier. So we have to remove the bracket here. For this, I'm going to have the first term. What you have here, the first term here is going to multiply everything that you have in the second bracket. So I'm going to have k multiplied by k plus 1 K, this K multiplied by K plus 1, K plus 1. Then the second term, which is plus 1, is going to multiply all the terms that you have in the second bracket. So I'm going to have plus 1 multiplied by K plus 1, K plus 1. And sometimes you can decide to put 1 or you can decide not to put 1. It doesn't matter. But because I'm explaining, that is the reason why I put plus 1. Because whether you put 1, if you put only plus at the front of this bracket, we know that 1 is there as a mathematician, okay? So you might decide to put 1 or you might decide not to put 1. So K times K is what? K squared. K times plus 1, that is what? Plus K. Plus 1 times K, that is what? Plus K. And plus 1 times plus 1, that is what? Plus 1, okay? So here I'm going to have K squared plus 2K plus 1. You can see now. So now, if you take the expansion of this bracket, you're going to arrive at K squared plus 2K plus 1. So let us put it. K squared plus 2K plus 1. Now, looking at this, you can see that what we have at the left hand side, please pay attention, is equivalent to what we have at the right hand side. Hence, this statement is true. You understand? The statement is mathematically true. You can write you cannot put your answer like this. Since the left hand side is equivalent to the right hand side for all the 3 steps, the mathematical statement is true or correct. You understand? So that is the solution to that question. If you have any question as touching what we learned here, let me know in the comment section, okay? Before you go, don't forget to hit the like button and subscribe. Also, drop comments. You understand? Tell me what you learned in the video, okay? That will be all for this class. See you in the next class.